Alright guys, I have a little bit of a different video for you today. So we need to take a look at those fractional exponents that we were talking about last time and like how the heck do we do those? So this is normally like a lab that I'd have you guys do in class to see some fun patterns. Don't be super judgy of all my tabs. There's a purpose, okay? Not for right now, but just in the back of my crazy brain. And then I have Desmos over here so that I can just show you this math. Okay, so if we had to do 4 to the half power, I can go to Desmos and type that in. So we would do 4. And then to get up in the power, you do that little caret key. Then, because you kind of have to put two numbers up there, you want to do parentheses again. And then we just do 1/2. Oops, I guess I don't need that second parenthesis necessarily. But then it just tells me that the answer is 2. Okay, so we got that first one. Now, if I also type in right next to it the square root of 4, which you can bring up the little keyboard down here and get that square rooty button. So square root of 4, which hopefully we all know is also 2. So we're trying to look for a pattern here between these exponents and roots, because, I mean, why else are we talking about exponents if they don't have to do with roots? So the next one we have is 64 to the 1/3 power, which is 4. And then if I do the cube root of 64 to the first power, which like this is not the same thing, but I think if we go to functions, somewhere in here you can get a cube rooty. Yeah, right there. Now right now it says n root, so I think I actually have to type in a 3 first so that it knows I want the cube root. Maybe? Nope, it wants me to type it in now. I see. Okay, it's alright, we're learning together. So let's click on that little gray box and we're going to put the 3. And then we'll do the 64 to the first power, which 64 to the first power is just 64. So also 4. So hopefully maybe we're seeing a thing. So then the next one, we are doing 8 to the 2/3 power, which is 4. And then they've rewritten that now as the cube root. So let's bring that little n root back up so it can be a 3. And then in it, we are 8 to the 2nd, which is also 4. So like we're always getting the same thing. Let's try this next one. Hopefully maybe we're seeing the things. We got 16 to the 1/4 power, which is 2. And then they're just taking the 4th root of 16. So we gotta bring up that funky root again. 4. Because 16 to the first is just 16, which is also 2. So I don't know if you're noticing, but kind of like, I wish I could point and that you could see what I was pointing to. Maybe you can see my pointer. Whatever the denominator is became my root, and whatever the numerator was kind of stayed back as your exponent. And that kind of happened for all of these. So the 2 came out and became my root because I was the square root, and then 4 to the first power is just 4. The 3 came out and became my root, and 64 to the first power is just 64. Same thing with the 8. The 8 is interesting because the 3 came out, became the root, and then 8 to the 2nd. Now you can think about this a couple of ways, which is super nice. Like I can square that 64, and the cube root of 64 is 4. But I can also take the cube root of 8, which is 2, and square it, which is 4. So kind of order doesn't matter there, which is super nice. And so let's maybe make a guess on this next one. We got 25 to the -1/2 power, or 0.2, which I hate, but 0.2 is just 1/5. So if you were thinking that this had to be something with a 5, because the 2's on the bottom, like taking a square root, the 5 did show up, and the reason it shows up on the bottom is because of that negative. So if I take the square root of 25 to the -1st power, 0.2, because the negative power you're not allowed to have. So moves it to the, oh my gosh, is this going to change it to a fraction? Do it. Ha! Oh my god, sorry. Anyways, didn't know. Okay, last but not least. And I'm going to do some notes with you guys. 2 to the third power. Then outside, the parentheses, we got to the, my word, half power. Which we know we could just distribute that in and call it the 3/2 power. Oh my god, how yucky. And it won't let me hit the little fraction button. So, let's see, now we're taking the 2, because the 2 will be the denominator, so square root. And then 3 times 1 is 3, so 2 to the third, which is the same thing. So like, hopefully you're kind of seeing that pattern that whatever the denominator is becomes the root, and whatever your exponent was your numerator. But this is curious, and if we think this through, like 2 to the third is 8, and I can't take the square root of 8. Like, that's an irrational number, and so that's why these numbers here are so nasty, and that's why I can't change them to fractions. Okay, so hopefully that was kind of a nice way to see that pattern. Oh my gosh, those are just all my files. It's no biggie. Let's get this going here. Okay. So, let's do this. This is what we hopefully just saw, that if I have a number to a fractional power, so any number on top over any number on bottom, and I put this on page 90, by the way, then I can rewrite that as a rooty boy, where I take the denominator and it goes outside as my root. So this tells me my index. So this is like your index. What root are you taking? Root you taken. And then A, the numerator, stays with that x and becomes your exponent. So A is like the exponent that you're doing. Now, the thing about this is, though, is if I can, like if I'm looking, I can go backwards and forwards too, I should say that. If I have a root, then I can take the b and put it under and make it a fractional exponent. So whatever is the exponent here stays, but then b goes under it, and then I become a fractional exponent instead of a root. So that's fun, you can go both ways. But when I'm trying to evaluate how much I have, I always like to do the root or the index first, because that's going to make me smaller, and if I can be a smaller number, that's so good. And then I do the exponent part second, because an exponent is always going to make me bigger, and I don't want to deal with big numbers if I don't have to. Okay, so let's do some examples here. We have our little poof book that I put on 89. We can put more examples outside if we need to, but this is just that same shortcut I just showed you. Whatever your exponent stays as your numerator, whatever your index is goes under and becomes your denominator, or vice versa. The denominator comes out, becomes your index. So some things that we want to do are just becoming comfortable with rewriting them. So if I look through and I notice that they all have roots, that means I'm going to rewrite them as exponents instead. So the number under is 63. It's going to be my base number. The 3 is its exponent. 5 is the index, so it goes under. So we're just rewriting it. Taking a root, making it a fractional exponent. Same for number 2. Negative 25 is my number. 4 is the power. 3 goes under. For number 3, we got 124 is my number. 7 is my exponent, so it stays numerator. 6 is my index, so it goes under. Now we should be able to go the other way as well. Like if I notice and I look through the problems have no roots in them, we're going to be rewriting them with roots. So I can kind of go through and put those all in there right now. Okay, so my number is negative 57. The denominator comes out and becomes your root, and then the 4 stays with the 57. And mathematicians aren't super picky here. The 4 can be under the root or outside the root. It kind of doesn't matter. It just belongs with the 57, so either way is fine. I typically put it under the root, but it doesn't matter. So 13 is my number. 2 is under, so it comes out, becomes your index. Now, when it's a 2 and 3 stays. I don't really need to put it because we all understand that a root without a number is the square root, so either answer here is fine. And then last but not least, 204 is my number, 8 is under, so it becomes my root, and 5 stays in. Now here's where things can get real interesting, because we also know how to simplify roots. And so when I kind of go back and look at that first one that I did there, it was making me a little bit uncomfortable to leave it that way, because when it says that I'm 57 to the 4th power, that really means that I have 4 negative 57s. And if I'm taking the cube root, then I'm looking for groups of 3. So I have a group of 3. And so I could really simplify this and make it negative 57 outside, and then leave a negative 57 inside. And then the same thing can happen here. The 13 to the 3rd means I have 3 13s. And I'm taking a square root, so I'm looking for groups of 2. So like a 13 would come out, and the other 13 didn't have a buddy, so he would have to stay in. So these simplified answers to me feel a little bit nicer. Now if you don't feel like you're quite there yet, that's okay. We're just talking about rewriting for now. But now on this one, I'm looking for groups of 8, and that 204 I only got 5 of. So I'm not going to be able to take any out, and I don't want to do 204 to the 5th power, like that ain't happening. Okay, so now we're going to try to evaluate some of them, which was where I was talking about I like to do the root first. So I take care of the denominator first, and then I do the exponent or the numerator. So when I look at this 36, I could rewrite it, but we want to try to get used to not rewriting it and just think about what root you taking. And I'm taking the square root, and I can take the square root of 36. It's 6. But that 3 is still there, and I haven't done it yet, so the 3 has to stay. And now I have to do 6 to the 3rd, which is 6 times 6 times 6, which is 216. So I can do all that without a calculator. Okay, so for part B, we got 64 to the negative 1/6 power. And I always like to think about what root you're taking. And I'm taking the 6th root of 64. And so a really good guess, like if I'm taking a 6th root of a pretty small number, then it probably has to be a small number on its own. I think it's 2, like 2 times 2 is 4, 8, 16, 32, 64. So the 6th root of 64 is 2. But then we're still to the negative 1 power, and we're not allowed to have negative exponents, so this boy's going to have to move to the denominator and become half. Oh, I love this stuff, it's so fun. Okay, so 16 to the negative 1/4 power. Again, that denominator is what I always like to take care of first, like what root you taking. And you're taking the 4th root of 16. Now taking a 4th root is like taking a square root twice. So like the square root of 16 is 4, and the square root of 4 is 2, and so the 4th root of 16 is 2. But that negative 1 is still there. You haven't done anything about the negative yet, so this one also becomes half. And then last but not least on this one, we are 8 to the 4/3 power, and what root you taking? And you're taking that 3rd root, and I can take the cube root of 8, it's 2, to the 4th power, and 2 times 2 times 2 times 2 is 16. Alright, let's check out what example 3 is. Oh yeah, same deal. Okay, love it. These are just written in the other form. Do I love it? Let's not do these. I mean, we can rewrite them in their other form. Let's do that. We're not going to evaluate. Oh, with the calculator. Ugh, don't even want to do that anyways. Read. Yuck. I'm just going to rewrite them. So that 23 would stay. The 3 is your index, so it would go under. So 5 to the 3rd. Yeah, I can't do that because I can't take, I looked at that first one, I was like, how do I even do that? I can't take the cube root of 23. And I don't want to do 23 to the 5th power. So I'm just leaving it like that. So if you can't do it without a calculator, like I'm not feeling that, that negative 124 would be 4 over 5 power. Because the 5 is the index, it goes under. And like I don't know the 5th root of 124. Like it might be 2. No, definitely not. 3? No. I don't know. Can't do it. These two I can rewrite though, and so this one's going to become a fifth root of negative 1012 to the 8th power. I could get a group of 5 there. Alright, let's take one out. But then we still going to have 3 left in. So like I can simplify a little bit there, but the fact is all these numbers are irrational numbers, and that's why I cannot do it without a calculator. So we're just kind of rewriting, which is fine, or maybe simplifying a little bit. And so same idea here, I'm going to rewrite that. It's going to be a fifth root, because 5 is going to come out. Negative 128 to the negative second. Now again, still shouldn't have negative exponents, and so like this whole thing needs to move to the denominator, which should kind of mean that we should rationalize this. Let's just do it. It'll be fun. So right now I have 2 128s, and to rationalize it, I need to have a group of 5. So I'm going to need 3 more of those. So that's how I'm going to rationalize here. Because then when I multiply, I'm going to have to the 5th power, and the 5th root of something to the 5th power will just become that thing. So my denominator is negative 128. Because like I'll fully be able to group that up and take it out. My numerator, however, is going to be the 5th root of negative 128 to the 3rd. Because that times 1 is itself. Oh my god, that was so fun. Okay, try your homework, you beautiful people. Miss you.